Hi friends, here in this video we'll see a problem on flat belt drive, and for that here is the question. A flat belt runs on a pulley 1 meter in diameter and transmits 8 kilowatt at 200 rpm. Assuming angle of lap as 170 degree and coefficient of friction as 0.25, find the necessary width of belt if the maximum pull is not to exceed 200 Newton per centimeter. Width of the belt, neglect centrifugal tension. So this is the question in front of us. Now I'll be reading this question again in steps and write the data before we start solving the problem. So the first step would be to write the data. Now in the data, mention the type of drive, because we are having problems related to chain drive, then related to rope drive, related to V belt, and this problem belongs to flat belt. So I'm mentioning the type here. It runs on a pulley 1 meter in diameter. So D is given 1 meter, the diameter of pulley. Transmits 8 kilowatt power. I'll multiply by 1000 to convert it into watts. Then at 200 rpm. Assuming angle of lap as 170 degree, that is theta. So multiplying by pi, dividing it by 180, because we need to convert theta in terms of radians, and it gives me the answer as 2.97. Coefficient of friction is 0.25, that is mu. Find the necessary width of the belt. Width of the belt is denoted by B. If the maximum pull is not to exceed 200 Newton per centimeter, so that is the maximum pull given, 200 Newton per centimeter, width of the belt. Neglect centrifugal tension. So in this problem they have clearly mentioned we have to neglect the centrifugal tension. Now starting with the solution part, first I'll use the formula of power transmitted because it is given. So let's get started with the solution part. The power transmitted by belt is given by T1 minus T2 into velocity of the belt. I am keeping it as equation number 1. Next, I will use the belt tension ratio to get the relation between T1 and T2. Mu value is 0.25 given, and theta in terms of radian, that is 2.97. I am getting this answer as 2.10. So therefore T1 is 2.10 times of T2. Keeping this as equation second. Next I'll go for the calculation of velocity of belt. Highlighting the formula, velocity is pi dn by 60, where d is the diameter of pulley and n is the rpm or speed of the pulley. So therefore V will be equal to pi into diameter is 1 meter given and speed is 200 rpm, dividing that by 60. So the answer of V, velocity, comes out to be 10.47 meter per second. Now once the velocity is known and also the relation between T1 and T2, I'll put them in equation number 1. Power is 8 into 10 raised to 3 watts. Then T1 is 2.10 times of T2 into the velocity of belt is 10.47. So therefore T2 value comes out to be 694.93 Newton. Once I know the value of T2, I am going to put it in equation number 2 in order to get T1. And T1 comes out to be 1459.54 Newton. Now since it is mentioned in the question that we have to neglect the centrifugal tension, so when we are neglecting the centrifugal tension, the tension in tight side, that is T1, becomes the maximum tension for us. So in order to find the width of the belt, because that is the question, and they have given that maximum pull is 200 Newton per centimeter. So here I am going to apply a concept that if the belt is having width of 1 centimeter, because it is given maximum pull is not to exceed 200 Newton per centimeter width of the belt, it means if the width of the belt is 1 centimeter, it is going to resist a load of or a pull of 200 Newton. So if 1 centimeter can resist a load of 200 Newton and we have to find the width of the belt, so the load for which we are designing the belt is the maximum load for us, and that is tension in tight side having the value which is 1459.54 Newton. Now for this much amount of load, what is the width of the belt? Denoted as B. Next I am going to cross multiply them. So B will be, it comes out to be 7.297, or I can say it is 7.3 centimeter, multiplying it by 10. So therefore B value will come out to be 73 mm. So that's the answer. So this is the belt cross section. T is the thickness of the belt and B is the width which we have just now found out. Its value is 73 mm, and as mentioned in the question, we had to find out this width B and we have calculated it, and with this the problem gets completed.